Recording.
All right. Hi there, everyone. We are Group 4, and this is our presentation for Math 2A's differential equations. And our topic is market equilibrium, stability, and time paths. So in this following presentation, we're going to go over some of the question we have, the things that we're going to solve for, and we're going to go one by one through all various parts of the problem. So let's get started. All right, so before we begin, just a little background, some background information about the topic. Well, one of the fundamental concepts studied in economics is the relationship between supply and demand. This relationship is what helps determine a whole lot of things, including the price of products and services in the world. And we can define supply as what the market provides and demand as what the market desires. So to model and utilize this relationship, we can use functions of both supply and demand to find really valuable information. In this case, for the first part, A and B, we're going to be solving for what's called the equilibrium price, or the price on what the market agrees on. So in other words, this is where supply and demand will meet. Just to kind of give you like an idea, but like if demand's too high, suppliers will lose sales. And inversely, if supply is too high, or if demand's too high, suppliers will lose sales. Inversely, if supply is too high to meet demand, money is wasted. So this is kind of like the practical application to what we're going to be solving today. And in the following presentation, we're using what's given in the problem, some outside knowledge and the application of calculus and differential equations to solve for various economic problems. All right, next slide. And here's our question. It looks like a lot right now, but in short, what we're going to be using right here, if you can see that Q of D and that Q of S, that is the demand equation. And on the right there, that is going to be the supply equation. And we're also given that formula down there for equilibrium price and some other variables here. So this is our question. We're going to go more into depth through the various parts, and through the various parts, we're also given more information. So yeah, let's continue. Next slide, please. And just to give you again, wrap your mind around this. Here's just a really sketched out graph. This is by no means fully accurate, but again, this will come really into play in parts A and B. So just graphed out here is your demand. We're graphing out demand and we're graphing out supply, and where they intersect there is that equilibrium price. So just the two equations that we were given and an introduction of the problem, and these will really come into play in the next two parts. So I'm going to pass it off and we can get started. All right, so.
Okay, in this part, we will talk about, we will substitute the equation of the demand and supply into the price adjustment equation. So by a few simple steps in the right-hand side, you can see by setting the demand and supply equal to each other, we will get the price at equilibrium is P star equal to D0 plus S0 over D1 plus S1. Now, in the next step, we will substitute the demand and supply equation into the price adjustment equation. So we have the demand equation is this, and the supply equation is this. We will substitute into this equation in the next step. Our goal in this step is showing that our equation for the price over time is PT equal to P0 minus P star multiplied by e to the ct plus p star, which c is equal to negative lambda multiplied by d1 plus s1. So all of this is constant. Lambda, d1, and s1 is constant. Okay, now we substitute the equation of the quantity of demand and supply into the price equation. We will get the, after all, we will get dp over dt is plus lambda multiplied by d1 plus s1 multiplied by b is equal to lambda d0 plus s0. So as we can see, all the d0, s0, d1, s1, and lambda, they're all constant. So we can solve this by using the first order linear differential equation. This is in standard form already. So we're starting to find the integrating factor. We got the integrating factor is e to the d1 plus s1 multiplied by lambda t. Then we multiply both sides by the integrating factor. We'll get this equation, the very big one right here. And as we can see in the left-hand side, equation is pretty long, but it is in the reverse form of the product rule. So we can change it into d over dt and multiply by, no, that is the difference. So e to the d1 plus s1 lambda t multiplied by t multiplied by b. Now back to our solving step. We will take integral of both sides and get the final equation is p equal to p star plus c1 e to the power of negative d1 plus s1 lambda t. We're given, okay, sorry. Okay, now we will get the initial value at t equal to 0, substitute to our equation pt, and we'll get c1 is equal to p0 minus p star. So our goal is achieved. Right here, we got pt is equal to p0 minus p star e to the ct plus p star. This is our equation about the price adjustment equation that we achieve. Now in the part B, we will evaluate if the market is equilibrium globally stable or not. So as we know that the market is equilibrium if for every initial price level P0, the price equation PT will approach P star as the time approach infinity. Okay, now we will use the model of the price adjustment that we found in part A. To find if that is equilibrium or not, we will use the limit of PT as P approaching infinity. Substitute that T into the limit, we will get e to the power of ct will reach to negative infinity. So e to the power of negative infinity will be 0. That's why we'll get the limit of pt will approach p star. So we can tell that is, yes, the market equilibrium is globally stable. And easier to visualize it, we graph it like this for you guys. As you can see, the graph is approaching P star as time goes by. Now I'll pass the next step to Jude. Oh, Kristen.
Yes, thank you. So in part C, we're trying to understand the market clearing time path. And to do this, we assume the two functions given, the function of demand with respect to time and the function of supply with respect to time. If we set those equal to each other for all t greater than or equal to 0, we find the function of the price with respect to time, and we get, the function of price with respect to time is equal to d0 minus d1 times pt plus d2 prime pt is equal to negative s0 plus s1 function of pt minus s2 p prime t. And dividing both sides, we get that pt is equal to negative s0 minus d0 over d2 plus s2, and p prime of t is d1 plus s1 over d2 plus s2. And as you can see, this is essentially a first order linear differential equation in standard form. And by finding the integrating factor, we get e is equal to, or e to the power of d1 plus s1 over d2 plus s2 times t, which is negative, and multiplying the integrating factor on both sides, we get, on the left-hand side, reverse product rule. Solving for pt, we get that pt is essentially the equilibrium price plus c1 e to the power of d1 plus s1 over d2 s2 times t. And by setting it equal to the initial value of 0, we get that the pt is equal to the initial price minus the equilibrium price times e d1 plus s1 over d2 plus s2 times time plus the equilibrium price. And in the next slide, we're trying to understand if it's true for any market clearing time path that we must have pt approaches the equilibrium price as time approaches infinity. And to do this, we take the limit of our function, which gives us, next slide, please. By taking the limit, we see that as that t approaches infinity and e approaches infinity as well. This means that the item's price will always be exponentially diverse as time goes by. Therefore, it is not true for any market. And in the next slide, yep, I think this is June.
In this part, we will be showing the relationship with real values. And in this case, we are given a price, which is $5 in the 0 months, a demand equation and a supply equation. We will show what the price is after 10 months and how is it affected by it and how supply and demand change. For this problem, we will be using substitution when solving. So we got 3 equations, P0 equal to $5 and quantity and of demand and quantity of supply equation. So we need to find P10, which is when the time is in the 10 months, and the derivative of the equation as well. So when we compare the two given equation of quantity of demand and quantity of supply equation, we will both get the value for the constant variable. D0 equal to 30, D1 equal to 2, D2 equal 4, and S0 equal 20, S1 equal 1, S2 equal 6. And we can substitute those into the equation of initial price equation, which is when P equal, when the time is 0, we can find that the constant value is 50/3. And then we can substitute the P asterisk into the equation, and we can find that the P T is 1/3 multiplied 50 minus 35 exponent power of 3/10 T. And after 10 months, we can substitute, we can put 10 months into the equation, and we will get around negative $217.66. And when T becomes large, price decrease and approach negative infinity. That means that the market has crashed and will continue to crash. And we can use the equation PT, derive it, and plug into the quantity of demand and quantity of supply equation. And when you compare both of the equation, we get that quantity of demand is equal to quantity of supply, which means demand and supply are expected to increase exponentially. Next slide, please. Conclusion, we use calculus to show the economic relationship between supply and demand. We proved that the price was globally stable with a function and utilize stability argument to show its adjustment path. We also solve for the point at which supply equal demand and showing how this reflect a market clearing time. At last, we demonstrate our knowledge by solving and analyze the relationship with a given price and a set of supply and demand equation. Thank you for watching our presentation.